Okay, so I've got what seems to be a really complicated thing that we're going to do in this video, but we're going to work through it, and you're going to see how it goes. So the question is, I got this function that I made, and it looks kind of scary, but it's going to turn out to be not all that scary. And this function is y equals x squared minus ln2 times 2 to the x. And that's what I've graphed. And I want to know what is the average value of this function between 2 and 5. So to sort of show you what I'm talking about, I will just sort of take this and y equals, let's put this back in here. On the interval, 2 is less than or equal to x is less than or equal to 5. So I only care about that part. And I want to know what the average value is on that part. Well, we can sort of say, let's say it's going to be 3-ish, 3 to 3.5-ish. So I'm going to sort of guess that's going to be my rough guess. And I might be right, I might be wrong. I think I'm probably in there, in that ballpark somewhere. Okay, so how are we going to do this using calculus? Well, what we're going to do is we're in the integral scheme of things. So we are going to take the integral. Now, I could have made this easier, or I could have made it harder, but I made it exactly the way it is. So I want to know, what is the antiderivative of x squared? So what function, when I take the derivative of that function, will it give me x squared? And so remember, we had my sort of rule for antiderivative in power functions, and I'll let you think about it for a second. The antiderivative of that is going to be x cubed divided by 3. Now, what is going to be the antiderivative of ln2 times 2 to the x? Now that one looks really, really bad. It looks really vicious. But I've actually just set it up for you so that it's just a memorization thing. And so if you memorized some of the stuff we were doing in the previous chapter, you'll know that. Pause for dramatic effect. The derivative of that is going to be 2 to the x, and so there's not going to be a minus sign coming out, so it's going to be 2 to the x. Okay, so this function here is the antiderivative of my original function. And so what is that antiderivative giving me? Well, it's giving me the area under the curve. Okay, so let's find area under the curve. Let's do a little bit, do some more typing. Okay. How in the world does the blue line match up with the green shaded part? That's the question for this video, is how does the blue line match up with the green shaded part? And what I'm going to do is I'm going to say that if I take the blue and I find its value at 5, its value at 5 is 9.9 2/3. So the value of, so right here, nine and 2/3. Well, I can plug that in. So I can plug 2 in here. I get 8/3. 8/3 divided, or I get 8 divided by 3 minus 4. So I get 8/3 minus 12/3 equals minus 4/3. Okay, so if I come back here, if I plug in 5 into this, I get 5 to the 3rd power, and you can do this on your calculator. Well, I'll just do it right here. I can do 5 to the 3rd divided by 3 minus 2 to the 5, and I get that number. Now if I plug in 2 there, I get that one, sorry, that. Now what I want to do is I want to say, what is 9.67 minus 1.33? Why am I doing that? Well, you'll see here in a second. So that number, so I've got 9 and 2/3 plus 1 1/3 is going to give me 11. So that should be 11. Well, what's 11? I'm arguing that if I evaluate the blue function is the antiderivative of the pink function that we started with. And if I evaluate that at 5, and then I evaluate it at 2, and I subtract those two numbers, I'm going to get the area of this shaded region here. So if I go back up, there's my original function right there. And adding all kinds of layers of complication, I'm going to take the integral, numerical methods here, take the integral from 2 to 5 of my original function, and I get 11. So this green area, that green area has an area of 11. And the way that I get that is I take the antiderivative of the pink function, because the antiderivative of the pink function gives me the area under the curve, key concept. I evaluate that integral function at the endpoints 5 and 2. I subtract them and I get the area under the curve, which the computer is getting by numerical methods. Okay, that still doesn't explain how I can get to the average value. I haven't really talked about average value yet. So what I'm going to do is I'm going to say has an area of 11 and a base of 5 minus 2, which is 3. So the average value is 11/3, which is 11/3 is going to be 3.67. And my original estimate was between 3 and 3.5, and so I was wrong. It was between 3.5 and 4. So the average value is 3.67. Okay, how did I figure this out? Well, here's what I'm going to do. I'm going to give you a new thing to look at. And so I'm going to go 0 is less than or equal to y is less than or equal to 11/3, and 2 is less than or equal to x is less than or equal to 5. Okay. What have I just done? Let me turn some stuff off here. Let's turn this off. Let's turn this off. Let's zoom in. Okay. What I've done is the green is, so here you see the green poking out. It's got the blue in front of it, but it's behind there, and then it pokes out. And that green, we took the integral from 2 to 5, and we did it both numerically and we did it analytically, although I didn't really show all my steps. And we found that that green has an area of 11. And it's got a base of 3. So I wanted to say, what simple rectangle has an area of 11 and a base of 3? So throwing that back up there again. What simple rectangle has a base of 3 and an area of 11? One that has a height of 11/3. Okay, so my light blue rectangle has the same exact area as my green blob, but what's really nice is that as much of the green blob as poking out of the rectangle, if I could sort of if I could make, okay, so this is the next thing I want to do. Okay, so imagine that the green blob is made out of wax and the light blue rectangle is a beaker. And so I've got this odd shaped thing of wax that's poking out of the top of my beaker. And so now I put the whole thing on a hot plate and I melt the wax. Well, as I melt the wax, this is going to melt and it's going to flow down into these parts that are not covered. And so basically, the melted wax will completely fill the beaker. So the height of the beaker is the average height of the wax blob. Okay, that's where I'm going to leave that lecture. You can watch it again if you need to think about it, and or get an explanation from someplace else as well.